My name is Sawyer West, and today we will be talking about finding prime numbers fast. We will be using various mathematics and C++ to go and expedite the process. But for now we will start with a naive solution. Here's our overview of the code, our header file. We want to be able to store the prime numbers when we find them in some vector. We want to output to the user what prime numbers we found, and we want to be able to time the speed at which we can find prime numbers. And we don't have to do any of the coding to implement these features because they've already been done. So we will include three libraries: Vector, IOStream, and Chrono, which will do these three things for us. We will have a method which finds the primes. It will take in some number of primes which we want to find. Let's say we want to find the first 1,000 primes, for example. That would be in this amount here. And we will have some method that we're running inside of it that checks to see if a given number is prime. We also want to be able to print out all the primes to our console, so we'll have a function called print primes. And we want to be able to conduct speed tests. And a test may be composed of many trials. So, what does the start of our execution look like? Well, we want to include the header file that we just wrote out. And our code will start running at the main method, as all C++ programs do. We'll declare some amount of primes that we want to find. Let's say we want to find the first 10,000 primes. And we'll run 100 tests for speed. We will find this amount of primes, and then we will print out those primes after we're finished. Then we will conduct the tests to see how fast we can find those primes. Well, how do these methods work? So let's say we're looking at how we print primes. We take in the vector of primes that we found, and we index through each prime in the vector. We start at the 0th index. We go to the size of the vector, and we increment each time this value right here as we go through this loop. And we print out prime index, which is this bit right here, is the value at that index. And then we have a new line, and then we do it again for the next one. Fairly simple. So that's how we print our primes right here. We're gonna not cover at this very moment how we find the primes. We're going to leave that more towards the end of the video. For now, we're going to move on to the speed test. So it takes in a number of trials and the amount of primes we want to find. First, we're going to declare some average. And then we're going to run a loop which adds the speed of each trial to this average. And after this loop is completed, we're going to divide the average by the number of trials we did, and then return the average. For each speed trial we do, we start our clock, we find the primes, and then we stop the clock. Then we see how long the elapsed time in between the start and stop is, and we return that value in seconds. Well, then we just turn that value. So at this point, our program is finished executing, but we still didn't cover how we find these prime numbers. It's important to note the code we've gone over previously will remain largely unchanged. Maybe a few things here and there, but they don't really matter at all to how fast we can find primes. They're just there to help us see how fast we find prime numbers. But the following code, in which we actually find the prime numbers, is going to change a lot. So we start with our naive solution. We have our amounts of primes that we want to find, and we declare a vector. And we put our first prime in it, which is 2. So we start at 3. We say, okay, is 3 prime? Because we call this isPrime method, and if it is, we add that to our vector. And then we move on to 4, because we're not at the prime size yet, unless amount is equal to 3, or 2. Well, 2 in this case, because we found 2 primes. So then we increment. Get to here. Well, how do we test if a number is prime? Well, we have this candidate number that we feed in. And we say, okay, if none of the numbers in between 1 and this candidate are divisors of the candidate, then this number is prime. So our divisor is 2, starts off as 2, divisor less than the candidate, increment divisor. If the remainder, when the candidate is divided by the divisor, is equal to 0, then we know that this candidate is not a prime. So we return candidate is prime. So we're going to validate. It seems like it's working correctly. The first prime is 2, the second prime is 3, 5, 7, 11, 13, so on and so forth. So our program is working as intended. And our speed test indicates that we are finding the first 1,000 primes over 3 trials in about 1/10 of a second. And when we try to find the first 10,000 primes over 3 trials, our average time is about 17 seconds, which is pretty terrible. Next time we are going to go and make our code a little bit faster, and it's going to be very, very, very fast eventually. Thank you for watching.